Yes. See here, Lohit, and you can write along with me if you want. Oh, it's better to write, otherwise you will forget everything. Okay, so the elements of group 1 is nothing but which elements? Tell me. Lithium, sodium, then potassium, then rubidium, then cesium, and then francium. Right?
Yeah.
These the group 1 elements are called are called alkali metals. Okay. Some of the very important properties of alkali metals are, where are you seeing? Just check here.
I'm writing.
Okay, you're writing. Good. So some of the important properties are, the alkali metals are very good conductor of electricity and heat.
And aren't they soft?
Sorry?
Aren't they soft?
Yeah, it is soft, it is shiny. Okay.
And sonorous.
Yeah. So it is very good conductor of heat and electricity. And also they are very shiny.
Of heat and electricity.
Yes, it's a very good conductor of heat and electricity.
Oh yeah, they're stored in oil, and once they're after oil, out of oil, they get duller.
Yes, yes, yes.
When they're in contact with oxygen.
Yeah. Highly reactive, right?
Yeah.
Yes.
And they react they react really easily to water.
Yes. So lithium, sodium reacts with water, and potassium, if you put it like in the atmosphere, they react with oxygen and reacts very fast. So it is very vigorous. Okay, and one important thing is, unlike from the other groups, here the melting point decreases if you come from top to bottom.
Yeah.
So you can say the melting point decreases from top to bottom. Like if you want to write, so melting point, let me write like this. Elements and melting point. Elements, let's suppose.
Oh yeah, there's one more thing.
Yes.
Top to bottom, they get less vigorous.
Less
vigorous to iron.
Yeah, less vigorous. Okay. And so the elements are sodium, which is Na. Then, I mean, first is lithium. Sorry, tried right. Lithium, then sodium. So it is lithium. Where we use lithium, Lohit?
In phones.
Yes, in batteries, right?
Battery.
Batteries, yeah.
Yeah.
Lithium, Sodium. Where we use sodium?
Salt.
Salt. Very good. And potassium?
Banana.
Banana in the banana we cannot make, right?
Like not yeah.
So can you tell me somewhere like in the where we use potassium? We use in the matchbox. I told you, right?
Oh yeah, right.
Yes, yes. Potassium is nothing but K. Rubidium is Rb. Okay, so our melting point is 180 °C, 98 °C, 64 °C, 39 °C. So it is decreasing from top to bottom.
Okay.
And similarly, for the boiling point also decreases. The boiling point, it's a chemical properties. So, I mean, in the physical property of that, so lithium, and write like this. So elements and boiling point. What is the boiling point? What do you mean by boiling point, Lohit?
Uh, when like the temperature where the substance can like evaporate. So
Yes, yes. Not evaporate. Evaporation.
gas.
Yes, yes. Constitute gas. Like at a temperature where the substance becomes a vapor.
Yeah.
So vaporization, not evaporation. Evaporation is different thing. Okay.
Yes. Okay.
Yes. Oh, what is the boiling point of water?
Like 100 degrees.
100 degrees C. Very good. So for lithium, sodium, then potassium, then rubidium, the boiling point also decreases. So 1330 degrees Celsius is the boiling point, 890 degrees Celsius, 774, and cesium is 688. Don't need to remember the values. I'm just wanted to tell you that the boiling point is decreasing from top to bottom. Okay. So this was the physical property. We are talking about the chemical now. So in physical property, boiling points decreases from top to bottom. Now we'll discuss about the chemical properties. Chemical properties means how fast it reacts with different elements and how hard they are making making bonds with different elements. Okay. It generally describe how substance reacts with other substance. That's it.
Okay.
You can say, and it describes how substance reacts with other substance. So we are talking about the group 1, right?
Yeah.
So group 1 elements are very reactive. Group 1 elements are very reactive.
Is there reason? Because it has one electron in its outer shell.
Yes, you know that, right? That's why.
Yeah.
Great, good. And what is the reason behind that? Because one electron. Very good. I was not knowing that you know these things. Very good. One electron is present in the outermost orbit of the atom of the element. Okay? Because now sometimes questions comes like what is the what is the chemical properties of the group 1? So then you can write it is very reactive. But if you write like this only, this much only, you will not get the full marks. You have to write the what? You have to write the reason as well. You have to write the reason as well. What is the reason behind that? Okay, good, very good. And one thing like as we are talking about the group 1 only, so the group 1 elements are very exciting. Like with have like group 1 element have exciting reaction with water. Always reacts with water, and like no other elements reacts with water, except that group 1 elements.
They burst into flames with contact with water.
Yes. So group 1 elements have exciting reactions.
Can you just say they react vigorously with water? Yeah,
you can write like this. You can write like this. It is better to write like this. And what was the compound he makes after reaction?
Salt.
Yeah, salt. And one important compound it makes, the hydrogen gas. Okay.
Okay.
Hydrogen gas. Do you know what is the uses of hydrogen gas?
All I know, like in space, there used to fuel stars.
Okay, you just first write, then we'll discuss. This is very important.
Okay.
Okay. So where we use hydrogen is very good fuel. Even for the car also we can use. Recently Germany has launched one car which runs on hydrogen. Okay. So what happened now when you burn hydrogen gas? When you burn hydrogen gas in presence of oxygen, they form heat as well as water. You know how? Let's see. This is hydrogen plus O2. See here. See first, then write.
Yeah.
You're not.
I'm looking there.
Yes, it's okay. So H2 plus O2, that forms H2O. Okay. So when hydrogen gas burns in presence of oxygen, the product is water plus so much of heat, and with that heat the car runs. Okay.
Okay.
Then the question is, why not we use hydrogen for everywhere? Right.
Okay. Very flammable.
Yeah, that is highly inflammable. So that is good, right? But it is very difficult to make the hydrogen gas. And it is very expensive also. It is very expensive to make. Okay.
Okay.
Because from how will you make the hydrogen gas? From this group 1 reaction. So if you put the element of group 1 into water, they will form alkaline solution. Means the hydroxide of the element and the hydrogen gas. It is like what I am saying is, let's say if you put lithium into water, it will form lithium hydroxide plus hydrogen gas. Okay.
Okay.
So it is very difficult to make also, and it is very expensive because the group 1 element is, it is not that much available so that we can use lithium for making hydrogen gas, right? Although lithium is very expensive and it is very rare to found somewhere. So making hydrogen gas is itself, it's a you can say difficult task. Okay, that's why people are not able to make the hydrogen gas sufficiently to run the car and run the bike or run the buses. Understood?
Yeah.
Okay, so yeah, as you said that group 1 elements reacts vigorously with water. Vigorously means it
Very,
creates lots of heat and violently. Understood?
Yeah.
Lots of sparks are there. Okay?
Okay.
So I have some of the questions for you before going to this things. Let me share. If you can see.
Yeah.
Yes. So the question number 1. Correct sentence from the sentence started and enders. Starters and enders are there. You have to connect.
Okay. From top to bottom, boiling point decreases.
No. The sentence is from top to bottom of group 1.
Of group 1, boiling point decreases.
Okay, good.
From
bottom to top in group 1.
From bottom to top of group 1.
Wait,
Wait, one second. The vigor of the reaction with water increases.
Yes. Good. Okay.
All group 1 elements are called alkali metals.
Good.
And all group 1 elements react with water to make hydrogen and then alkaline solution.
Great. Next question. These are one-liners, so you can solve, I know. But the problem comes when we have to write the answer in proper way, right? I understand.
Yeah.
Yeah. Solve the second question.
Okay, do I just start from B?
Yeah, obviously.
Okay. So from top to bottom.
But can you plot? You don't know how to plot?
I know how to plot.
Yes, good. Okay.
Okay. From top to bottom of elements in group 1, their hardness decreases. For example, lithium is 0.6. Then when it goes to sodium, it decreases by 0.1. Yeah. So this means when sodium to potassium, it will be 0.4.
Yeah, can be. We cannot say the exact value, but yeah. What about the C question? C number 2C.
Predict the hardness of potassium, explain the predict. I predict that the hardness of potassium is 0.4.
No, you cannot. No. Say. You cannot say directly the value because you don't know the value, right? But you can say one thing, that the hardness of the potassium will lie between 0.5 and 0.3. Okay, you should write like this. Otherwise, like if you write 0.4 now, then they can ask you why. How are you saying? How can you say that the hardness will be 0.4 only? It can be 0.45 also, right?
Yeah.
So you cannot say like this. You should write like this, that the hardness of the potassium will lies between 0.5 and 0.3, because from top to if you are coming from top to bottom, the hardness is decreasing. Okay. Or you can say like this, because this is a 2 marks question. Then you have to elaborate little more, that you have to write exactly like this. The hardness of the potassium will lie between 0.5 to 0.3. And it should not be greater than 0.5 and it should not be less than 0.3. Okay. You understood? Yeah. Yes. So you have to elaborate like this. Then you will get full marks. Otherwise, if you simply say that it will be your hardness will be 0.4 because it is decreasing, so there might be a chance of reducing the marks. Okay. If you want to write, you can write this kind of answer, so that from the next time, if you have any exam, then you can write like this. You got it, right? How to write it?
Yeah. I have a question. Are the alkyl are the elements of group 1 the only alkyls in the periodic table?
Yeah, only.
Okay. Okay.
Okay. Question number 3rd.
Predict and describe in detail what happens when scientists add rubidium to water. Name the products of the reaction. Justify a prediction.
Yes.
When rubidium reacts with water, a salt will be formed because rubidium is an alkali.
Yes.
And hydrogen gas will also be formed.
Very good.
Because
actually, you have to write like this, that if you add water
because,
because
can you see it like this? Because when you begin react with water, a flame is burst out, and the hydrogen gas from there, something like that.
Yeah, you just write in your language, but you need to explain a bit carefully.
Okay.
You just write whatever you want to write in your language, but you have to explain a bit, because this is a 6 marks question, right?
Yeah.
So you have to write it in details.
Okay. Do I do question 4?
Yeah, you write the question 4 and explain this also.
Describe in detail trends in the physical and chemical properties of Group 1 elements. That's in Group 1 elements, from top to bottom, their melting and boiling point will decrease.
Very good.
They are sonorous, shiny, and brittle.
And it is very good conductor of electricity and heat.
Yeah.
And what about the chemical property? Because you have to write the chemical property as well, right?
Yeah. They react very vigorously with water. So from top to bottom, they react to the top. They react more vigorously with water.
Very
than
good.
The bottom.
So you can say the intensity of reaction is lowered when you come from top to bottom, right? Yeah. Yes, very good.
And when they react with water, salt and hydrogen gas is formed.
Very good, very good. If you want to write, you can write. Or is that okay?
Yeah.
It's better to write, I think. Anyway, you have to write. I will give you homework as to write these things. Okay.
Okay.
Okay. We'll come to this group of group 7. Group 7 is also very, very interesting.
I know that when like halogens,
Yes, 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 yes.
With an element from alkali metals, it's called an ionic bond.
What is ionic bond?
It's when a metal and a non-metal react, basically.
Okay, good. What happened if two metals reacts with each other, combines to each other?
It's a covalent bond between two non-metals.
No, I'm asking you. You are telling me now.
I'm asking a question. I forgot about that. It's a covalent bond. It's like a reaction between two non-metals.
I don't know. You don't know?
No.
Okay. So one metal, one non-metal reacts each other, forms an ionic bond.
Yeah.
Okay. Two non-metals reacts each other, forms a covalent bond.
Yeah,
okay.
that's what I said.
Yeah. Two metals react with each other, forms a called metallic bond.
Oh yeah. Okay.
Okay. Then now we'll discuss. Wait. The group 7 elements.
Okay.
The element of group 7. Okay. What are the group 7 elements?
Chlorine.
Bromine. Bromine.
Yeah.
I mean fluorine. First is fluorine, right?
Yeah.
So it is fluorine, then bromine, then iodine. Iodine, right? No.
Yeah. Wait, what? So
where is chlorine? Here it is chlorine.
Chlorine is after fluorine.
Yes, it's chlorine.
So it's fluorine,
bromine, iodine,
and astatine.
astatine. It is astatine. Statine.
Yeah.
Okay?
Yeah.
These are called halogens. So group 1 elements are also called halogens. Let me do it. I mean group 1, not group 1. So group 7 elements are also called halogens. It has very low melting point. Okay. I have very low melting point. All non-metals has low melting point. Okay. Remember these things. If you have to compare, if I gave you two non-metals like iron and carbon, okay, If I ask you what is the melting point of these two, which one has higher melting point? Then you can directly tell, sir, this iron is a metal, so metal has high melting point, and carbon is a non-metal, so carbon has low melting point. That's it. Understood?
Yeah.
So comparison between metals and non-metals are very easy. So metal has high melting point, non-metals has low melting point. Okay, and it also do not conduct electricity. Okay.
Okay.
They do not conduct electricity. Then why they are important? You tell me.
Because their materials are safe to use with electronics. Like there is like to protect electronics from like their wire breaking.
In electronics, we generally use silicon, germanium, right? Semiconductors.
Yeah.
But this is not semiconductor, right? Chlorine, bromine, iodine, and astatine is not a semiconductor, right?
Yeah.
So we cannot say that you use in electronics and something. And it is very brittle in nature.
In nature?
In nature means it is brittle. Okay. Brittle in nature means that these elements are brittles.
Can you just say they are brittle?
Yeah. I can write like this. Okay. If you don't brittle at room temperature.
At room temperature? At
room temperature. When we temperature changes, the brittleness also changes.
Okay. What did you say again? When the temperature increases, like changes,
that depends upon the material, because sometimes some elements have become softer and less brittle, and but some elements become more brittle when temperature increases also. Okay. But at room temperature, it is a brittle solid.
Okay.
Melting point will decrease from top to bottom.
Okay.
And boiling point also. So chlorine, bromine, iodine, astatine. Have you seen any element, Lohit? Out of these five, have you seen anyone?
Well, I know chlorine is a poisonous gas.
Yes, like okay. Where we use generally?
Chlorine.
Huh?
Like in water sinks to kill bacteria.
Yes, very good. Any other out of these five?
No.
Have you heard about the iodine?
Yeah.
Where it is available?
What?
Do we use iodine in our lifetime, like in a life, general life cycle?
Yeah.
Where?
Like in microscopes.
Iodine.
Like not in microscopes. Like it's used during when you use the microscope.
Yeah. Do we use anywhere else?
Yeah, but I didn't know.
Have you heard that the salt having iodine? No. Actually, in India, in India, one disease called I don't know what it is called. Like in that, the throat becomes like this. Okay, there is a disease. There is a disease. In that disease, what happened? The throat soars like this, which is the bigger throats. Okay, that is because of the less quantity of iodine in the body.
Okay.
When the scarcity of iodine in the body happens, now this kind of disease happens. So generally in India, what we do now, in salt we use iodine. normal salt. In normal salt, we use iodine as well. So we when we took salt as a food or something, then iodine also went inside and that heals that thing. Understood?
Okay.
So iodine is very important things. So what we were discussing that, yes, yeah. So fluorine, all like what about the state of these 5 elements? Whether it is in solid state or gas state or liquid states.
I know that chlorine is in gas state.
Very good.
Iodine is in liquid state.
Very good.
Fluorine, I think.
Iodine not in liquid. Sorry, iodine is not liquid. Bromine is liquid, right?
Yeah.
This bromine is liquid, not iodine. Iodine is solid.
Okay.
What about the fluorine?
It's
also gas.
Yeah.
But not sure about this astatine. It can be solid, gas, or liquid in room temperature. Okay. So that's why we cannot say that. Yes, we cannot come to any conclusion. Okay.
Okay.
Okay. So, yeah. So if you come from top to bottom in this, from fluorine to chlorine to bromine to iodine, okay, from top to bottom, melting point increases.
From top to bottom, the melting point increases.
Yes. And boiling point as well. So boiling point also increases.
The top to bottom.
From top to bottom, yeah. So means yeah, from top to bottom. Sorry, yeah. Yes. Means chlorine has higher boiling point than fluorine. Bromine has higher boiling point than fluorine. Something like that.
Okay.
Okay, so and one more thing I just wanted to tell you here, the properties, the chemical properties. These are the physical properties, right?
Yeah.
The chemical properties are the group 7 elements are reactive. So very reactive, highly reactive. It is also very reactive, like group 1. Okay.
Yeah.
And their reaction are also similar. But it is not react with water. It reacts with metals. Okay. So you can write group 7 elements. You can write group 7 elements are very reactive. Why?
Because they have 7 electrons in their output.
Very good, great. Because they want to make it 8, right? They have 7 electrons in their outermost orbit, so they wanted to make it 8, so that they just wanted to take 1 electron from anywhere. Okay. And all the metal have at least one electron at the outermost orbit. So what happened now? When metal comes near to this chlorine, bromine, iodine, they took one electron from the metal and forms a bond called ionic bond.
Yeah.
Understood? Because this halogen wants 1 electron and metals wants to leave 1 electron. So it is okay. So when both comes closer to each other, metal gives 1 electron to this group 7 elements and forms a ionic bond. Correct?
Yeah.
So you can write group 7 elements are very reactive because it has 7 electrons at its outermost orbit, and they wanted to.
Wait.
Yeah.
Can you say that one more time?
Yeah. Group 7 elements are very reactive because it has 7 electrons at its outermost orbit.
Okay.
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 7 electron at its outermost orbit, and they wanted to make 8 because to make to become stable, they wanted to make it 8. So when metals comes closer to these things, okay, so the halogens reacts with metal to form a metal salt.
The metal salt.
Yeah, like or you can say simply metal. Yeah, metal salt is okay. It will work. It's like if you take iron close to chlorine, it will form iron chloride.
Wait, so can you say that non-metal plus metal will form salt plus metal?
Yes, that is also okay. But here we are talking about particular non-metals, right? Halogens. That's why I'm writing. You can say, or you can say write like this. So wait. You can write like this. If you want to generalize, then you can write metals plus halogens will make metal halides. Halides. Metal halides. Halides means, example, iron is metal. Halogens, I'm taking chlorine. It forms metal chloride.
Okay.
Understood. Similarly, if iron combined with bromine, it will form iron bromide.
Okay.
Understood?
Yeah.
Yes. So remember these things. Next class we will finish these things and we'll start the group 0 elements. Okay?
Okay.
And I will share some of the questions in the Google Classroom. You just try to solve this. Okay? And one day I will test you.
Okay.
We'll discuss all the topics which we discussed. We have already discussed in the class. Okay? We'll discuss, don't worry about the test, but we'll discuss all the topics that we have already discussed in the previous classes. Okay? That would be the test for you. Then if we discuss more now, you don't have to remember for your examination. You already got everything in your mind. Okay? Yeah. Okay, then we'll meet next time. Bye.
Bye.